Hi class, in this video we're going to be talking about similar polygons. So for polygons to be similar, unlike triangles, you have to have every corresponding angle be equal to each other and every corresponding side uh, have the same scale factor to each other. So let's go over this example and I'll show you what I mean. So let's start with the angles. Here it looks like A as a shape geometry wise is corresponding to A prime. So the two angles here are the same. Great. T looks like it's in the same position as T prime here, and they're both 80 degrees, so that's great. And it looks like M and M prime are in the same position geometry-wise, and they both have the same angle of 90 degrees. And H is in the same position as H prime, and they both have 90 degrees. So what that means is every angle equals to each other. So I'm going to write that down. So angle M equals to angle M prime. Angle A equals to angle A prime. Angle T equals to angle T prime. And angle H equals to angle H prime. All of these angles are equal to each other. Does that mean that this quadrilateral is going to be similar? No, not necessarily, because unlike a triangle, if you have every angle equal to each other for a triangle, you can say that they're similar, but not for any polygon with 4 or more angles. As soon as you have 4 or more angles, you have to have two things that are true. All corresponding angles must be equal to each other, and in addition to that, all corresponding sides must all have the same scale factor. So those are the conditions that you have to fulfill in order to have a similar polygon. In this case, a similar quadrilateral. So let's kind of get started here. So let's start with the side MH. Which side on this shape will be corresponding to it? And if you look, it would be this side here, M prime to H prime. So what I'm going to do is I'm going to take my side for M prime and H prime and divide it for my side for M to H. And the length for M prime to H prime is 4.2. And the length for MH is 3. And if I divide that, 4.2 divided by 3 would equal to my scale factor. And in this case, that's going to be 1.4. Great. Now I have to make sure I check for all the other corresponding sides, and they all must also have the same scale factor of 1.4. So let's check for another one. How about HT and H prime and T prime? So if I check for that one, let's write that down. H prime to T prime. So H to T, 2.1 divided by 1.5. Okay, so upon calculating that, I also get 1.4 as my scale factor. Great, so now let's check for, let's go A to T and A prime to T prime. So I got A prime to T prime divided by A to T. Notice how I'm keeping it consistent. If I start with my my A prime and if I start with my bigger shape on the top, I always keep it on the top when I find my scale factor, and I always keep the smaller shape on the bottom. Alternatively, if I started with the smaller shape on the top, then I would start with the smaller shape on the top for every one of them as well. So right now I'm keeping it consistent. I'm starting with the bigger shape, the length on the top first. So here I have 4.9, which is A prime to T prime, divided by the corresponding side of A to T, which is 3.5. So let's see if I also, once I divide these, if I would also get 1.4 as an answer. In this case, I also get 1.4 as a scale factor. So now we just have to check for our last side, which is MA and M prime to A prime. So for M prime to A prime, divided by M to A, I get 1.54 for M prime to A prime, and then for its corresponding side, I get M to A is 1.1. So if I divide 1.54 divided by 1.1, do I get 1.4? In this case, yes, I do. I also get 1.4. Now, since the scale factor is equal for all four corresponding sides, that means I can say this quadrilateral or polygon is similar to each other because all the angles are equal to each other and all corresponding sides have the same scale factor. So hence, is this similar? Yes, they are similar.